In physics, one of the most common misconceptions is about mass and weight. We obviously know that both of them are not the same. We know that they are different. Mass is not equal to weight. But many people think of them as one of the same. The probable reason for this confusion between mass and weight is the day-to-day use of these terms. For example, when I say that I weigh 75 kilograms, note the use of language over here. I'm using the word weigh. That means I'm referring to weight, but I'm using the unit of mass. And when you get into a physics class, you are told that the unit of mass is kilogram and the unit of weight is Newton or dyne. Therefore, this confusion arises sometimes. But in this video, we will get a very good idea about what is the difference between mass and weight. Let's begin by trying to understand what is mass. Mass is the amount of matter in a body. I'm sure you have heard about this definition of mass of an object. So if I take any particular object, let us say I take an object, the mass of the object is the amount of matter contained over here. In numerical terms, I can say that it has got a relationship with how many molecules of this particular substance are there. Let us say 10 raised to 40 molecules. So these 10 raised to 40 molecules will contribute towards the mass of the object. And as long as this 10 raised to the power 42 molecules remain over there, the mass of the object will not change. So mass of an object does not change unless there are physical changes in the object. But if I take this object and keep it on the surface of the earth, we know that the center of the earth will apply a gravitational force. Of course, both of them apply a force onto each other by Newton's third law of motion. But let us talk in terms of the force applied by the center of this earth on this object. This force, which is applied by the center of this earth, is known as weight of the object. So weight of an object is basically force of gravitation. If I take the same object on the moon, there will be a force of gravitation between the center of the moon, and this will also be the weight of the object. But this is the weight of the object on the moon, which is equal to this gravitational force. I will call this Fm, and this force of gravitation, which is there, we will call it Fe. Obviously, Fe and Fm are different because of the mass of the earth and mass of moon are different. Therefore, Fe and Fm will be not be equal, and thereby weight of the object on the earth and the weight of the object on the moon will not be equal. They will have different weights. Please remember, this weight is actually a force. So let us keep in mind that weight is nothing but the force applied by earth onto that object when we have kept the object on earth, and weight on moon is the force applied by moon on that object when it is kept on the surface of the moon. Thus we can see that weights of an object can vary, can change depending upon where it is placed. Whereas mass of an object, there are 10 raised to 40 molecules here, there are 10 raised to 40 molecules here too. Therefore its mass remains the same. So we know now that weight is nothing but a force applied by the center of the earth or the moon, as the case may be. But we will restrict our restriction only to the earth for the time being. So if the object is kept on the surface of the earth, this is what the weight is. By second law, we know that force is equal to mass into acceleration. And with regard to earth, we know that acceleration is acceleration due to gravity on earth. And thus we get that well-known formula or equation, W is equal to mg. This is weight of the object. This is mass of the object. And this is the relationship between weight and mass. Weight is equal to mass into g. At a different location, probably on some other planet, the value of g will change. So you will have some other value g. Mass is going to remain the same. So weight will change and it will have some other weight w dash over there. Thus, we have understood the difference between mass and weight. Let us summarize this in the form of a table and see what are the differences between mass and weight. Mass is the amount of matter contained in a physical body. As we discussed, mass is the amount of matter, whereas weight is the gravitational force with which the physical body is attracted towards the center of the earth. Mass is one fundamental property of matter. Weight is not a fundamental property because weight will keep on changing based on location, where mass will not change. Mass has magnitude but no direction, so scalar quantity. Weight has both magnitude and direction, so it's a vector quantity. That is because weight is a force. Mass of a body is independent of the location. Again, the same thing, mass of a body does not change with location, whereas weight of a body changes with location as the acceleration due to gravity changes with the location. Instruments are used for measurement of mass: span balance, electronic balance, whereas weight is measured by using a spring balance. And finally, the unit for mass are kilogram and gram in SI and CGS units, whereas the SI unit of weight is Newton and CGS unit is dyne. Thus, the main takeaways from this video are that mass of an object is a fundamental property of the object and does not change, whereas weight of the object is given by mg and its value keeps on changing based on the location, because as the location changes, the value of g will keep on changing, and that w is a force, weight is a force, and hence a vector quantity. Let us get some more clarity on mass and weight. Let us say the mass of an object is, let us say, 20 kilogram. So its weight will be equal to 20 multiplied by 9.8 Newton. So this will give me 9.8, 196 Newton. Newton is basically kg meter per second square. So mass is 20 kilogram, weight will be 20 into 9.8, 196 Newton. There is one more way in which weight is sometimes represented. If the mass of an object is 20 kilogram, I am taking the same thing, 20 kilogram, its weight is also sometimes given as 20 kgf, where kgf means kilogram force, meaning that we are treating this mass unit as kilogram as a force. Therefore, weight is also given as 20 kgf, and that could also be written as 20 into 10 raised to 3 gf, gram force, because 1 kilogram is 10 raised to 3 gram. In other words, the weight of an object could be given in Newton or in kgf. If weight of an object is given in newtons, let us say 200 Newton, that would mean its mass is 200 divided by 9.8 kilogram. Whereas if weight is given as 200 kgf, that means its mass is 200 kg. So it is important to understand the difference between these two units, Newton and kgf, and of course that the fact that kgf is also 10 raised to 3 gf. So this mass will be 200 into 10 raised to 3 grams, and this 200 kgf is 200 into 10 raised to 3 gf.